Hello everyone, thank you for watching the video. I'm Paul Pen from Foresight Tech. This video, let's talk about distance from a point to a line in two space. Okay, so uh, suppose we have a line here. Let's see. Okay, uh, that's called L because this is in two space. Okay, that's a plane. A point outside uh, of the line. That's called P is the point. I can set up P is like X zero, Y zero. So what the distance we need to find? Okay, so that's the distance. D from the point P to the line L. What is equals? Let's set up the line. Okay, so the line equation, we can use general form. Okay, let's say if the line is this, is ax plus by equals c. Okay. Um, and then how we can find the distance? That's the problem. Because in general form, y is a linear function of x, and the AB will form a perpendicular vector, which is a normal vector. So we can use this. Okay, we can use this n equals AB. This is a normal vector, right? Okay, so therefore this is good. Now let's do this as a generally. Let's pick a point at any point A. If I say that's x, y, okay. So any point, if I link this, I get a vector, okay. This vector, let's say is V. V, if I know A and I know P, then I know the vector V, right? So see this distance, how this distance related to the vector. So we can use projection. Yeah, what we can say, oh, this is a normal vector. Can you see? Normal vector. So therefore, the projection. Do you believe it the projection? Yeah, see. That will be the projection, okay? The projection of V onto N. This will be the projection of V onto N. And therefore, what do we have? Okay. So we have this formula. So the distance from the point to the non L, okay, equals the length of the projection of V onto N. Okay, so this is the beginning, right? So that's important. So can we simplify? Okay, now let's simplify to get a specific formula. Let's calculate this. What's V? V is from A point to P, which is this vector. Is the end point, which is x zero, right? Minus x. Y zero minus what? See? So we have V. Now, what's N? We already have, right? Okay, N is A to B. Uh, let's do calculation for the projection. Calculate the projection. So the projection of V onto N. We have a formula, if you remember. That's a scalar of v, okay? And the coefficient, the scalar number is a fraction. The numerator is v, right? Dot uh, it's on to. So this is okay. That's my fault. So when we project the vector onto n, should be is a scalar of n. Okay, denominator will be n dot n. Check the formula, and then now we do calculation. What is v dot n? So v dot n definitely I know is a times x0 minus x plus b y0 minus y. Yeah, denominator. N dot n, a times a is a squared. B times b is b squared. So add together. The times n, okay, n is this vector. Uh, okay, and then the projection. Uh, we don't need to exactly find the projection, right? Okay, whatever. Oh, I can simplify a little bit more. Okay, sorry. Our purpose is not find the projection. Okay, our purpose is find, see, the length of the projection. The length of the projection uh, is the length of this. Okay, that's a coefficient. See, that's a coefficient. So therefore, can put the coefficient outside. So therefore, we have absolute of value of v dot n over n dot n, which is the norm of n squared to believe that the absolute value and n times the okay, and then we can simplify it, right? Okay, so definitely we can simplify one. See, we cross. So what do we get? We get v dot n on the numerator. The denominator will be the yeah the norm. Okay, so this time I definitely get a little symbol. The denominator is this square root of a squared plus b squared. The numerator, okay, is absolute value. So a, I guess 0 minus x plus b. The sum of product y0 minus y. Okay, let's put something together. Let's put these x0 y0 together. Why we put them together? Oh no, sorry, don't put the x together. Okay, let's put this y and the x together. And the reason is y-axis. A is a point on the line. So xy follow this general equation, right? Which is ax plus by equals to c. Okay. And therefore, I can simplify it. So therefore, this equals square root of a squared plus b squared. Now, what do we have? I have a x 0 plus b y 0 minus parentheses ax plus by. Okay, put them together. Okay, this one is c. Okay, because a coordinate x y is on the line. Ax plus by equals c. Okay, this is a 9, right? This is the 9 we talk about. So therefore, ax plus by is c. Okay, so we can take this away. So we have the formula. So the distance formula. See, the distance from the point to the 9 equals final is square root of a squared plus b squared. The numerator. Okay, so this one we take this away, which is c, right? Okay, therefore is ax squared. No, ax 0, by 0 minus c. Okay, we're done. That's the formula. Um, so we can extend this. We talk about a two space. Okay, I give a 9, give a point, and the so a 9 and a point. Um, what if now it's a three space? I give a 9, I give you a point how we can find the distance. Okay, probably we can talk about a little extension. What if? No question. Yeah. What if we talk about a three space, okay, and not a two space? This time let's look at if this is a 9, okay, it's still a 9, but that's a point. So we talk about the three space. This is a P. So therefore P has a three coordinate. So and the normal form, okay, is not easy to do. In this case, what do we do? We have another way, okay, to do that. We can set up a vector form, okay? So this time we have to set up a vector form. A vector form, which means I give a pointer. For example, A, I know. And then I know the direction, okay? Let's say this vector D. I know the point A. I know D, which is called vector form, right? We can use a vector form other than normal form so that we can, why we cannot use normal form, okay? Because mnemonic is many direction. It's not a unique, but the vector form is good. So D is unique. And this is the way now we can do. Uh, we can just link A and P again. See, we have vector V, right? This time project V on to L. And this will be the distance. You can see we have a projection. As you can get it. And this will be the projection of V onto D. So therefore, okay, so we can get something. Can you see? Do you believe this is the distance? Okay, the distance. So therefore, D, so dr from the point P to L. This one will be what? Will be different. Okay, so that's a vector. If I get this vector will be V minus projection of V onto N. But look at this triangle. The hypotenuse is V, and the bottom leg, okay, is a projection. So therefore, the orthogonal, okay, component which will be V minus projection, okay, and then the distance will be this, will be V minus projection of V onto N. Oh, definitely. Okay, this is another one. So if we talk about the three space, I have to use this way, okay, to do the calculation. We don't have a good formula, okay, to simplify this normal vector. Um, but if you like, you also can think about it, see if you have a good way, okay, to simplify this. That's all. Thank you for watching.